We will be waiting for a few more people to join, and we'll start. We will wait for 2 more minutes, then we will start. Arshia, I think we can start.
Okay, guys, now we'll start the presentation.
Share my screen. You guys can see my screen.
Yes.
So, hi everyone. Good afternoon. My name is Ayush.
Hello, everyone. This is Arshia R.
And today we'll be talking about Apache Oozie. So this is going to be an introductory session on Apache Oozie. So let's get started. So to know what Oozie is, we need to know what Apache Hadoop is. Maybe some of you must be using Apache Hadoop framework already. So it will be a quick introduction about Apache Hadoop. So Apache Hadoop is a framework to use to store and process large data sets with distributed processing across clusters of computers. And it delivers an high available service on top of the cluster of computers, and it has its own the high availability features and all to detect the failures and handle the failures. And the Hadoop developers uses the Oozie, the tool which we are talking about, the Oozie to perform the ETL operations uh, in a sequential order for the data. And let's know what exactly Apache Oozie is. So it is an scheduler system engine to manage the Apache Hadoop jobs like Peg, Hive, Scoop, and MapReduce. So good thing about it is an widely used software or a tool on the top of Hadoop. Yahoo uses it on the daily basis. Around 2 lakhs jobs every day gets run in Yahoo using Oozie. So and what the main purpose of Oozie is, it is to manage the different type of jobs that are being processed in the Hadoop system. And let's talk about the why specifically we need to use Oozie and why can't we directly run the jobs. So let's assume there are dependencies between the jobs that are specified by the user, or we can say by our requirement. So what this does is the Oozie flow is worked in directed acyclic graphs. So it consumes the information of one job and take that information to execute the another job or the next job. So and it is integrated with the Hadoop stack, tightly integrated with Hadoop stack. So we cannot run jobs other than which are available for Hadoop. So and the architecture center of it is an yarn, and it supports all the Hadoop jobs we talked about. And there are basically two main jobs which we do in Oozie. These are a workflow and the coordinator. So we'll be talking about workflow and coordinator later. Let's talk about the architecture of the Oozie. So as we can see through the diagram, it is an server and client based architecture. So client server based architecture, and in uh, in the Oozie, the client request to the Oozie server. It can send a request or trigger the jobs using CLI, using SDKs, using APIs or web request, whatever it may be. So it basically sends the request to Oozie server that we need to run this jobs. We provide the jobs, and the definition of those jobs, we need to write it in an XML file, and those XML files are stored in our HDFS. And the definitions of those files, like how it's going to run, just like the compiler, it is stored in the separate Oozie database, which is linked with Oozie architecture. And this architecture connects and communicates with the Hadoop cluster to run our jobs one by one. Now let's talk about the types I told you about. So there are basically two main types, which are workflow and coordinator, and there's also one new type which was introduced in the fourth version, which is the bundle. Oozie bundle. So let me first talk about what Oozie bundle is. Oozie bundle runs the coordinated jobs. The coordinated jobs are uh, the uh, the coordinated jobs are bunch of workflow jobs which we can be run using the triggers like the time trigger. We can trigger it like if you want to run some list of jobs on the 1 p.m. daily, you can do that, or you can coordinate that job to be run after you get some data. Like if you get the data from the first job, then trigger the second job. The coordinator works that way. And the workflow, the complete workflow will be talking about using the syntaxes and the examples. So Arsha will be talking about the workflows and will explain in the details what these actions and what are these jobs and what are the syntaxes of the workflow is. So Arsha.
Okay, guys, now let's talk about Oozie workflow. As we all know, Oozie workflow is basically collection of action and control nodes, and these action and control nodes are arranged in directed acyclic graph, which is DAG. And these workflow definitions are written using HPDL language, which is a Hadoop development language, which is an XML-based language. And workflow nodes, we know it consists of action and control nodes. Let's talk in detail about the action and control nodes. So let's dive in detail about what is action nodes. So as the name suggests, action nodes are nodes which perform some kind of jobs, some kind of operation or some processing, etc. There are many actions which we can perform in Oozie. Some of them are hive action, pick action, map reduce action, swoop action, shell action, and email action. And now let's talk about what are control flow nodes. So control flow nodes, basically, they control the start and end of the workflow execution. This marks the beginning and end of the workflow, like start, end, kill, etc. And it provides us a way where we can control the workflow execution. It also consists of something like decisive node, fork node, join node, etc. So let's talk in detail what are the types of control flow nodes and what it actually does. So we have actually 5 kinds of control flow nodes. First is start control flow node. So start basically is where the workflow execution starts. That it marks the start of the workflow. And similarly, end control flow nodes, it marks the end of the workflow. Here is where the workflow ends. And we have kill control flow nodes. It marks that whenever the job is killed, you can do that using kill work control node. And fourth one is the decision workflow node. Suppose you want to you provide a condition to Z, and you want it like if suppose the condition is evaluated to be true, then you want a corresponding transition to take place. And if suppose it is not evaluated to be true, that time you want some other transition to take place. That time you can be using decision node, which is one of the control flow node. And the last one is fork and join. Fork and join control flow nodes are opposite to each other, and they're usually used in pairs. So fork node, it divides the path of execution into multiple concurrent paths. So here you can see in the diagram, fork node and join node. The fork node has divided hive action 1 and hive action 2 into different concurrent paths. They both are interdependent, not dependent on each other. And the join node basically combines the data. So fork node divides the action and join node merges all that. Now let's talk about the flow diagram given over here. And we know the start, the fork node, join node, and end. These are the control flow nodes in Oozie workflow. And the email action and hive action given here are the action nodes. So let's talk about the flow, how it's going on. So first we have the start. This is where the workflow starts. As soon as it starts, the user will be receiving an email action saying that the process had started, and then we perform fork node where we are dividing, where we want two jobs, which is hive action 1 and hive action 2 jobs to be running concurrently. They'll be running parallelly, and they are not dependent on each other. And afterwards, when this both job completes running, they both will be combined, and it will be merged. It will be joined to hive action 3, which is also hive job. And after, when all these jobs have run successfully, we'll be receiving an email action, which is either successful mail or a failure mail. And after we receive that, the workflow ends over here. Now, since we're focusing more on hive action here, let's talk about what is hive action. Okay, so basically, hive action, we know what is hive. Hive action consists of we running a few Hive queries in a cluster. So we know Hive, it's an SQL like interface language for Hadoop. And all the queries, all the user-defined functions, libraries, etc., we have to be dump that in a file, and all that has to be dumped in HDFS location. And Oozie always uses HDFS location. So we are dropping all the files required over there. Now to perform Hive actions in the script or in the file, there are few important or compulsory elements which we have to include. So some of them are the name of the job tracker. So we know what is job tracker. Job tracker basically it is responsible for taking client requests. So whenever a client requests, it assigns them to particular task tracker on the data node. That is the job tracker. And we know name node. So the next important element is name node. A name node is the center of HDFS location. So this is a master node. It will provide tasks to the data node. And third important element in the Hive action is a script. So the script contains the queries which we have to run. Okay, guys, now let's move on to Oozie coordinator. Next slide. So talking about Oozie Coordinator, it is basically a framework. There'll be few triggers provided, and we can schedule the workflow job based on those predefined triggers. There are actually two types of triggers in Coordinator. One is a time trigger, and the second one is a data availability trigger. Let's talk a little about time trigger. So time trigger, as the name suggests, suppose you want to run a job every day at 3 p.m., then you can do it using time trigger. And there are actually three attributes which are important in time trigger. First one, the ST over there is the start time. This is basically the time when the running of the job takes place. And F here is a frequency. Frequency is it specifies interval for subsequent execution. And FT is the end time, which means after the end time has passed, there is no new execution taking place. There's no permission for that. Okay, now let's talk about data availability trigger. We know that suppose you want to schedule a job at 3 p.m., we'll be using time trigger. But also you want something like schedule a job at 3 p.m., but if some sort of data is not available, then do not start the job. That time we can use both data availability trigger at that time. Okay, guys, now next part will be handled by Ayush.
So let's talk about the coordinator here. So how coordinator looks in the code and how we write the coordinator. So basically what coordinator does is it actually just an enhanced version or pro version to run the workflow jobs. So it basically runs the workflow job with some tweaks and with some more features. So what are those features? Just like Arshia explained to you about the start time and the end time. So we can mention the start time and the end time of the jobs to be running and the frequency of how often we want it to run. So like here, these five represents the job to be run every 5 minutes. So it will be like a cron job. So this job will be running every 5 minutes, whatever we pass here. So this job will be running in each 5 minutes, starting by this time, like the 15 and the universal time controller thing. So this will be running for 1.5 hours in each 5 minutes interval. And here we have provided the workflow path which will be redirected. So here we have used this one global parameter which we have configured in the property files. So you guys must know what property files is. We use it to support our application to configure it. So here are some of the properties or the configurations we have mentioned to use for using in our other XML files, like the domain name node, the master node, the which job tracker we are using, like we're using Yarn Resource Manager here. And if we want the library part to be explicitly set, so we have mentioned it here. And the retries, so it is an important configuration here, like how many max retries we want and what will be the intervals for the jobs to be retrying. So it will be, if the job fills, it will retry every minute, max 2 times. So 1 plus 2, that will be the job. Our job will be running 3 times if it's filling again and again. And we have also need to mention this property, which is rerun dot fail nodes equals to true if we want the uh, Oozie or Hadoop system to rerun the failed jobs. And there is a fork join validate dot fork join type which we have set here as true, since we are using fork and join in our application. So it needs to be true. If it is false, the Oozie won't allow us to use fork and joins in our application. And here we have provided workflow paths just to retrieve it, where we can easily use this variable name directly to locate the actual job and the coordinator file which we have used. So now Arsha will explain you about the actual job and the flow of the actual job.
Okay, guys. So we know workflow.xml is an important file to schedule an Oozie job. Let's study a little bit about how the flow of workflow, how it usually goes on. So let's talk about the workflow. For that, we have to give the we basically in the first line we're providing the version of the workflow which we are using, and we provided a name for the workflow. The name is simple and POC, and there are few parameters we know in the properties file. We have added the name of name node and the job tracker. So we are I'm just defining them in a global thing wherein I can dump all parameters over there, so that we can improve the efficiency of this file. Or else we have to put this job tracker and the name node name everywhere in the every action we perform. So that's why to avoid that we are doing it over here. And every because since you have done since you have defined the parameters over there, so when if you have to use it in the workflow, you are to always use the dollar symbol and the name of the parameter here. Okay, now let's start. We know in the flow diagram we saw it starts with a start email. So here is where the start mark. Ayush, can you highlight that? Start to start email. So it starts with the start email, and first action we want to perform is an email action. So we're just putting the action name as email start email, and the action is email action. And two signifies the mail ID whomever you want to send to the user or to you, and the subject is what subject you wanted. Here start demo dollar wf dot name is the name of the workflow which we have defined it in the top, and the body signifies any message which you want to send to user or to ourselves. And here is where the body closes and the email action stops. Suppose the email action has run successfully, then it goes to fork node. If it has not run successfully, then it goes to failure mail. Then since if it is successful, it goes to fork node, which so we're starting to fork here, which means we are dividing the task into concurrent parts. So they both will be they how many ever parts you want to define, they'll be running concurrently to each other, and they are not dependent on each other. So it starts with fork node 1, and the path start both of them starts, we are having first and second logic. These are basically hive action 1 and hive action 2. We have named it as first and second logic. So it starts with first and second logic. So it basically comes down. Here is where we have first logic. It's a hive action. So we have defined action cred as hive 2 and the name of it as first logic. And this is an email action which we have defined in the below line. And since I told you that the path of the script is very important whenever you have to run a hive job. So all the files like HQL files or any kind of action jobs you want to run, all those have to be in a script, and all the job properties file, XML files, everything has to be dumped into a HDFS location. So we are just providing the location of HQL file over here. So because Oozie always refers to the HDFS location, so that's why every file you prepare, you have to dump it over there. So we are just providing the path of it over here, and this is how first logic ends. And if this is successful, then it goes to join node 1. Since I told you that first logic and second logic, they both are Ayush, can you come below? Just below.
Yeah.
Scroll down. Yeah. So can you highlight this join name? Yeah, so if these both things are successful, then it goes to join name as join node. But this is the name of the join we have given, that is join node 1, and that will be joined to third logic, which is our third hive action. Okay, so again, we know it is a hive action, so we are just specifying that over here, and we are also providing the script for the third HQL file. And if this is successful, if all of these are successfully ran, then it just provides you a successful email. And if it has failed, then it provides you a failure mail. The mail action, it is same as I explained you above. Can you scroll down? If all of these are done, the task usually will end. And after that, the task usually will end. And if it has failed, then the job gets killed. And it gives you a message like action failed and error. And here it gives you what is the error message, and also gives the last action name. So WF last error node. Can you highlight this line, Ayush? Message action failed error message. Yeah, this one is basically the last action node name it provides over here. And can you please open the HQL files? So we are basically, since it is a simple, we just created a simple POC wherein we have a very simple hive action. So we basically created a dummy table in the database, which is named as EMP, and we are just trying to create other table using that data. So all the three, simple hive actions are similar. We're just creating a table over here. Okay, I should go to PPT. Guys, we actually couldn't able to find any of the open source for explaining you how the flow goes. So we cannot be showing you how the demo is, but we can explain you how actually the workflow is. Okay, so we understood the coordinator, we understood the job properties, we understood the workflow. Now let's talk how it actually happens. So whenever we are running, we okay. So let's talk about the diagram given over here. So whenever this is a coordinator. So whenever a coordinator job is getting submitted, that time Oozie service, it will parse this coordinator XML file. And as I told you, coordinator and workflow both are XML files. So Oozie service will parse that, it will validate it, and if it is validated, then it generates a job ID. As soon as it generates a job ID, the status will be marked as prep stage. And uh, and when the time, suppose in the coordinator you have set time like it should run at 5:31 p.m. like that, and as soon as the time is reached, that time the status will change to running stage, from prep to running stage. Now at running stage, if the user wants to terminate, if he suspends or terminates the job, that time it will directly go to suspend or pause stage. And if he does not terminate it and it is running and it has encountered an error in the files or something, that time this status will be failed, and then it will be killed simultaneously. And if there are no errors, everything ran smoothly, successfully, that time it gives you succeeded, like that. Okay guys, now let's move on to some of the next slide. Let's move on to the Oozie commands. Okay, since I've told you that we're not providing a demo for it, let me just explain you how the flow actually is. So we told you that all the scripts and all the files etc has to be put in the HDFS location, because Oozie always refers to that. Now there is a command to copy the data from our local path to the target path. So we'll be using Hadoop fs minus hyphen put command to copy the data over there. Here hyphen f represents override. Suppose you have already dumped the data and you did some changes and all, and you want to add it over there, you can use hyphen f over there. And since we're using XML files a lot, the coordinator and the workflow is XML. To validate it, we have a command, Oozie validate workflow or the coordinator XML. This basically validates, it just checks the syntax of it. If the opening and the closing brackets are fine, everything is fine. Just check the basic syntax of it. And it returns okay or error. Okay, and then before running a file, we can dry run the properties file. Every time we run the Oozie job, we always run a properties file. And for that, we're using Oozie job hyphen config, the properties file name, and dry run. This basically runs it doesn't run the file, it just, checks if there are any errors, checks for the permissions and stuff. And suppose you want to actually run the job, you can just remove the dry and you can simply give run over there, and that time the actually job runs. And here is where it returns you a job ID. The job ID is dependent on two things. Suppose you are not using a coordinator file, you're just using a workflow file and a job properties file. That time it returns a job ID and it gives you with an extension hyphen W, which means it is only using workflow. And suppose you also use a coordinator file, that time when you get a job ID, it will have hyphen C, which means it's a coordinator because you have included coordinator in that. And suppose you want to check what is the status of the workflow. That time there is one command from Oozie, that is Oozie job -info, the coordinator or the workflow ID, depending on the situations. And suppose you want to kill the job, that time you can be using kill command over there to kill the job. Next slide. Okay, now let's in short discuss about differences between Apache Oozie and Airflow. Both of them are orchestrate network, their framework, orchestrate framework, which means it will automatically schedule jobs, both of them. So languages used in Oozie is like it uses Java and Airflow uses Python. The adoption is high in both because most of the companies and everywhere they both are used. And authentication, how authentication happens in Oozie, it follows Kerberos. Kerberos, we know it's an authentication request. It's an authentication service request. And custom is also one of them. It basically has a custom token, user ID, and password kind of stuff, which is used by Oozie. And Airflow uses Kerberos, and it also uses LDAP, which is known as Lightweight Directory Access Protocol. This is one of the application protocol. It's used to maintain distributed directory information. Let's talk few cons about Oozie. So, Oozie is implemented worldwide. It's used in most of the companies, example, Google, Yahoo, etc. And since we know Oozie is it's a native to Hadoop ecosystem. So, big job, hive job, email actions, most of the things which we can do in Hadoop, Oozie supports. And talking about few, and also there's few pros of Oozie also. Like again, it automatically schedules a task. It has time scheduler. Suppose you want to run a job specific time, you can use Oozie for that. And we have few prongs of Airflow. It's a dynamic generating path, which means suppose you have 2-3 workflows which follow similar pattern of running. That time you don't have to manually code it. So Airflow does it automatically for you. And again, same as Oozie, consists of time scheduler and command line trigger. Again, as I told you, there are 3 ways where we can run Oozie job using command line interface, APIs, etc. Okay, let's talk about the cons. One of the biggest cons of Oozie is that it uses only XML language. There's only one way you can, define the workflow and the coordinator flow, and only using XML language. And one of the problem is like if you have to manage, if you have a lot of frequent jobs, it's very difficult to manage it. And there's difficulty in customization. Same goes with Airflow. Even Airflow, you cannot do a lot of customization over there, and it is very less flexible. Okay, guys, thanks a lot. If there are any doubt, you can just ask. Thank you.
And guys,
any doubts are welcome.
Yeah, for the time being, we will be sharing the feedback form. So please take a minute to
And
fill it.
there's only, yeah.
And if you have any doubts, you can ask us. So I have shared the link for the feedback form. Please take out a minute to give us a feedback.
And guys, anyone has any doubt about the session? Okay, thanks a lot.
Okay, so if you guys do not have any doubts, you can left the meeting.
Thanks a lot, guys, for attending the session. It meant a lot for us.
Yeah, thank you.
Thanks a lot. Thanks a lot.
Thank you, Arsh.
Thank you for attending.
Thank you,
Surendra.
Surendra. Thanks a lot.